Session. It is module 4 quantum mechanics and lasers. Now we go with the lasers. What is the introduction of lasers? And in lasers, spontaneous and stimulation emission of radiation. Now here we go with the lasers. What is a laser gives? Laser is an abbreviation of light amplification by stimulated emission of radiation. What does a laser stand for? L, light, A, amplification, S for stimulated, E for emission, R for radiation, emission of radiation. So laser is a light amplification by stimulated emission of radiation. So laser is a device which is used to produce a parallel and highly coherent light beam of high intensity. Laser is a device which is used to produce laser device. Laser light is highly chromatic. Highly monochromatic means single frequency, and it produces a highly parallel beam of light and highly coherent source of light, and which is having a high intensity. So laser light is highly coherent. Coherent means the phase difference between the two waves is either zero or constant. Coherent light is where the two waves are said to be coherent when the phase difference between them is either zero or constant. So laser light is highly coherent, highly monochromatic, high intensity, and they travel in parallel beam of light, and it will not divergent. So what is meant by coherence? It is what I have explained is being told here. Coherence, two waves are said to be coherent if the phase difference between them remains constant or zero or constant. So phase difference should be zero or either constant. So then the two waves are said to be coherent source. Coherent source of light is required for producing good and steady state interference and diffraction pattern. You have seen in your lower classes, second PUC, in the wave optics, you have seen the diffraction pattern and interference pattern, and these two, to obtain diffraction and interference pattern, it is a coherent source of light that has to be used to have a sustained interference or a diffraction pattern. So here coherent light, what is the source of it? Normal light, what you see in your general LED light or whatever, the tube light or a normal light, those light is not a laser light. That means it is not a coherent source of light. The laser light is only coherent source of light which can be used to obtain a diffraction and interference phenomena. Here monochromatic, I have used the laser light is highly monochromatic, means it is having a wavelength of single frequency. It is having a single wave, that is frequency is constant, that is only one frequency. Wavelength and frequency are interrelated. It is not having a range of frequency, it is having a one particular frequency. If it is having only one particular frequency, then that light is called as a monochromatic. Mono means single, chrome means color, single color, that is single frequency, wavelength of single frequency. It doesn't have a range of frequencies. So we have seen what is a laser and what are the characteristics of a laser light, and we have defined what is meant by a coherent source. Next we see the energy states of an atom. In an atom there are three states. Energy states, we have three states. One is ground state, the other is excited state, and the other one is a metastable state. What is the three types of the states? Here is ground state, excited state, and a metastable state. What exactly is a ground state? The lowest possible state where the atom can remain there for an infinite period of time. It can stay there for an infinite period of time. It can sleep there for an infinite period of time. That state is called as a ground state. It is the most stable state. When the atom sits in that period for a long time, it is the most stable state, and the atom is staying there for a long period of time because it is the most stable state. Next is the excited state. Excited state is a state where atoms remain in this state for a very short period of time, that is 10 to the power of minus 8 seconds. You imagine what is the shortest time where it is spending. Where the atom sits in that state for a very short period of time, that is called as an excited state, and the time period is 10 to the power of minus 8 seconds. It can't sit there for a 10 to the power, it is sitting only for a very short period, that is 10 to the power of minus 8 seconds. And this state is above the ground state, and this state is higher than that of ground state. Then it is a very unstable state because atom cannot stay for a very short, it cannot stay for a long time. Very short period of time it is staying, so it is a unstable state and it is higher than the ground state. Next is a metastable state. What is a metastable state? Metastable state is a state where it is not as stable as ground state, and at the same time it is not unstable as that of an excited state. Here atom can sit in this state for a period of 10 to the power of minus 3 seconds. That is relatively larger time when compared to the excited state, but lesser time when compared to the ground state. So it is an intermediate state, so it is called as a metastable state. Next we see the induced absorption. In this session we are going to see what is induced absorption, what is spontaneous emission, and what is stimulated emission. Now induced absorption is, you can see here, E1 is the ground state and E2 is the excited state. E1 is the most stable state where an atom can sit here for an infinite period of time. What is an induced absorption? Here an atom at the lower energy state, here incident photon is there having a particular energy which is greater than the difference in the energy levels E1 and E2. When the photon having certain energy greater than the difference of energy E1 and E2, when this photon is falling on such a system where atom is sitting in the ground state, this photon is taken by this atom and reaches to the ground state. You can see here, you cannot see the photon here because the photon energy is being taken by the atom and that atom reaches to the excited state. This phenomena of absorbing the incident photon by an atom sitting in the ground state and reaching to the excited state, this phenomena is called as a induced absorption. Induced means you are making this photon to fall onto such a system and this photon is absorbed by this atom, reaches to the excited state. So the atom has come to the excited state. There the process of raising atoms from ground state to excited state by the phenomena of induced absorption. Next we see the spontaneous emission. What is spontaneous emission? See here, as I told you previously, here E1 is the ground state and E2 is the excited state. By induced absorption, the atom has reached to the excited state. What is excited state? Is a state where an atom can sit for a short period of time, 10 to the power of minus 8 seconds, which is very small time period. So it cannot sit here for a longer time because it is in the excited state. So what will happen? The atom reaches down to the ground state, and when an atom transfers from a higher energy state to a lower energy state, the photon is being emitted. This photon, it is emitted. This is emitted because an atom is moving from a higher energy state to a lower energy state. Why atom is coming from higher energy state to lower energy state? Because E2 is an excited state where an atom can sit for a very short period of time. It cannot stay there, immediately it comes down. The moment atoms comes from higher energy state to a lower energy state, photon has been given out. And this type of emitted photon, this type of emission is called a spontaneous emission, where no one will make this atom to come down. It itself come by its own, giving rise to a photon, emitted photon. And this type of emission without any instigation of any external force leads to the spontaneous emission here. Leads to the spontaneous emission. This light is not a coherent source of. This light emitted by the spontaneous emission is not a coherent source of light. Coherent source of light is the source of light only when the phase difference is 0 or constant. So spontaneous emission do not give out the light which is of coherent. Okay. Next we go with the stimulated emission. What is stimulated emission? Stimulated emission occurs only when see here in this state here, this is E1 is the ground state where an atom is sitting for an infinite period of time. Due to induced absorption, this atom has gone to a higher energy state. If this E2 state is a metastable state, if this E2 state is a metastable state, what will happen? It is the atom is sitting in the metastable state for a period of 10 to the power of minus 3 seconds. So it is a metastable state. If E2 is a metastable state, atom is sitting in this state for a period of 10 to the power of minus 3 seconds. That means it is not as short as excited state and at the same time as long as ground state. So in this process, when the atom is sitting here for a certain period of time, in this process, if a photon is incident on such a system, if a photon, external source of photon is incident on such a system, it will call this atom to come down. This photon is calling this atom to come down. This path will be unaffected. You can see here the photon, incident photon is also coming out and another photon has been given out because of transition of atom from a higher state to a lower state. See here, this is an emitted photon and this is an incident photon. Why there is an emission? Because this photon is calling this atom to come down. It is not doing by its own. It is stimulating this photon, this electron, this atom to come down. This is instigating. This is calling this. So this is incident photon. So when this is an incident photon and this is an emitted photon. When incident photon is making the atom to come down, or the incident photon and the emitted photon will have the same characteristics, that is the frequency, wavelength, velocity and phase. So whatever the characteristics of incident photon will be taken over by the emitted photon. So the emitted photon and the incident photons both have the same velocity, same frequency, same wavelength, and they are in phase. They are having same phase difference. When they are having same phase difference, it is nothing but a coherent source of light. So here this type of emission, by stimulating this incident photon in the presence of stimulation, in the presence of this instigating photon, the emission has been given out, and all the characteristics of the incident photon are being taken away by are being same as that of an emitted photon. So these two photons have the same frequency, same velocity, same phase and same wavelength. So this type of emission with same characteristics as that of incident photon, which is instigated by the external source, this is called as a stimulated emission. Stimulated emission occurs only when there is a metastable state where an atom can sit for a 10 to the power of -3 seconds. This type of emission is stimulated emission. Now what are the characteristics of a laser light? The laser beam is highly monochromatic. Highly monochromatic, that means single color or single frequency. Highly coherent, because incident photon and the stimulated and the emitted photon, incident photon and the emitted photon have the same characteristics of wavelength, frequency, velocity and same frequency, velocity, wavelength and phase. So it is highly coherent. Highly directional. It is moving in the form of a parallel ray, so it is highly directional. Highly focusable. It is focused, very sharply focused. It is less divergent. It is not divergent as that of a normal light. So these are the characteristics of the laser light. Thank you.